Hello, 7th graders, and welcome to your first flipped math lesson. Before we get started going through the lesson itself, I do want to just point out a few boxes that you're going to see. First is this recording box, and that's pretty new to you. It goes with my recording. So this box is really for me. It helps me record things, I can pause, I can stop it, and really it tells me how long my lesson is. So don't let that box bug you. And then this box you've seen last year, and this one just allows me to flip pages and so on. So that box shouldn't be new. All right, now that we went through some of the basics, I'm going to go ahead and get started with today's lesson, and that is lesson 1-1 on variables and expressions. With this lesson, we have two main objectives. First, you should be able to identify variables, numerical expressions, and algebraic expressions. And two, you should be able to write algebraic expressions for word problems. Now, it's okay if you don't know what those words mean yet, because by the end of this lesson, you will. All right, here's our warm-up, which I think I'm going to skip today because I want to get through the lesson itself. So we're going to start with this table. And I noticed right away that there are some blank spots. So more than likely, we're going to have to do some work. In order to find out what kind of work we have to do, it's always good to go back up and read the directions. So in bold print, it says, how many miles can you drive on 1 gallon of gas? Use the table to find out for each type of vehicle. All right, so if I take a look at the subcompact first, it tells me it can go 330 miles on 10 gallons of gas. So then comes my blank spot over here. And I need to know how many miles can I go per gallon, meaning 1. All right, now if we're breaking something apart like this, we have a whole and we're breaking it into 10 parts, this is a time when you use division. So what we're going to end up doing here is dividing the miles by the number of gallons each vehicle goes, because that will leave us just with that one part. So if I do that down here, I have 330 divided by 10, and I get 33. So the subcompact can go 33 miles on 1 gallon of gas. I can do the same with the compact now. Same idea occurs. I'm going to take those miles, divide it by how many gallons, which is 10, and I get 30 miles per gallon. Then I have the mid-size compact, so we're getting a little bit bigger as we go along. That vehicle can go 245 miles on 10 gallons of gas. And if you divide that out, that is 24 5/10. Then we get that sports utility vehicle, which is a big one. And as you can see, that can only go 175 miles on 10 gallons of gas. So that leaves us with 17 5/10 gallons, or miles, excuse me. Then we come to a pickup truck. And there are 2 blank spots. Above, we had how many miles, and then we had the gallons, and then we were able to divide it out. This time, we're missing a key piece of information. So we can't really solve it. We can't say it can go 20 miles on a gallon of gas because we don't know. These are the times in math where we use variables or letters to stand in. And I'm going to choose X, meaning X is the number of miles here. All right? Because we don't know how many miles that pickup truck can go. We just know it goes some miles. So we have X. It can go X miles. Now we need to fill in that other blank. We need to figure out how many miles per gallon. Now, you're not going to get just a number because we don't know what that X is. But we can use that same pattern we've seen above in order to solve this. And if you look at all of these ones up here, we did the same thing. We took the number of miles they gave us and then divided by how many gallons that vehicle could go. And we're going to do the same thing. Well, how many miles did this vehicle go? It went X. That's how many miles it went. Well, then we divide, just like we did with all the others. And then, gallons is 10. Now, that would be our answer, X divided by 10. So when we do this, we are using variables. And again, when you don't know the number, you use one you use a variable to stand in for it. And a variable is just a letter, any letter that stands for a number. And this letter could be X, it could be Y, A, B, C, D, so on. And, well, it's really up to you sometimes. Sometimes a book tells you what to use, what letter, and sometimes you have to identify one for yourself. And then we have algebraic expressions. Now, this is a mathematical phrase that uses variables, numerals, and an operation symbol or symbols. So, when they talk about variables, again, it needs to have some sort of variable. It could have an X, Y, and so on. It needs to have numerals. A numeral is a number. A lot of the times you'll see some numbers in there. And then an operation symbol. And operation symbols are just those plus, minus, multiply, and dividing symbols. Any of those in there. Now, one key thing to pick out, however, is there is no equal sign. When we're talking about an expression, it is not equal to something. 3 plus A is an algebraic expression. If I said 3 plus A equals 6, it's not, because it has that equal sign. So an algebraic expression has no equal sign. And I believe this next page here lets us practice. We're going to identify expressions. Now in that light blue box, there are 7 different expressions. Some of them are numerical, and some are algebraic. Now, we did just go over what algebraic expression means. Again, it has that keyword algebra in it, so it has those variables. Now, numerical, if you take a look, it has that numeral again. That means just numbers. So when they're asking you to tell the difference between numerical expressions and algebraic, if you have just numbers, it's numerical. If you have even one variable, all right, like that X, Y, A, and so on, that makes it algebraic. So we're going to start at the top, and we're going to do one of these together. And I see that first one is 3 plus B. Well, I take a look, and I have to decide, are there just numbers there, or is there a variable? And this B here really tells me. This B is a variable, so it goes under algebraic, 3 plus B. All right, let's see. Then we could do the same here with, well, why not 5 minus 5? Well, I take a look. I just see numbers, so it must be numerical. All right, now it's your job, however, to finish the rest of these. So in a moment, I want you to pause this video and just complete these 5. And then when you're done, we're going to check to make sure we have them all right. So go ahead and pause the video now. All right, I hope you had a shot or a chance to finish this. And what we're going to do now is just place them where they're supposed to go. And I'm going to just start over here. We have that C minus 6. Well, C is a variable, so that one goes there. Then we have 12 plus 4. Well, again, I don't see variables. Those are just numbers. So that's numerical. Then we have this one, 3Z. Now, I'm just going to tell you this. When they have a number, that coefficient and a variable together like that, that does mean to multiply. So really, we have 3 times Z there. But it works the same way. Is there a variable? And the answer to that is yes, that's Z. So 3 times Z goes down there in our algebraic expressions. And I'm going to continue through. Oh, 20 divided by 2. Well, there's a 20 and a 2. Those are numbers. So that must be numerical. And then we have 14 times P. Another way to show how to multiply, and that has a P, so that is algebraic. All right, that's the first objective. Now we're going to move on to the second one. And this is where we're actually going to start writing out expressions now, because they don't always just give you the number and the variable. Sometimes you're going to have to figure out what to write. And a good way to start this is looking for keywords. Now, you will see the 4 symbols up there, operations. Adding, subtracting, multiplying, and dividing. What I need to do here is just identify common phrases or terms that I hear that tell me to add or to subtract or so on. So, for example, I keep saying add. That is one way I know that I'm supposed to add something together. 3 plus A, 2 plus 4. That tells me to add. Another one would be that plus. All right, so there's add, plus, and there's plenty more. And in fact, I'm going to have you write as many as you can in a moment. Same with this one. I could say minus. I could say subtract. For multiply, well, again, I could write multiply. And then for division, I could write divide. Now, again, I'm going to have you pause this video for just a moment, and I want you to try to write in as many as you can during this time. And when you think you have as many as you know, well, then we're going to go ahead and start the video back up, and I'm going to just write some down as well, and hopefully we'll have some that match. Who knows, you might even have more than me by the end of this. So go ahead and pause the video now. All right, so something else you might see is increased by. There's an increase or an increased by. Something else you might see, in addition. You might see more than, and so on. And again, you might have a few more, but I'm just going to try to keep going here. For subtracting, you could see minus, subtract, the difference between some numbers. Let's see, what else is there? Decreased by. There's a decrease. And of course, there is less than. All those mean to subtract. Then we have multiply, which I think I'm going to write in blue. You can say multiply. You can say the product. Let's see. I bet there's even another one. You can say times. And then really for divide, there's only two you normally see. Divide or quotient. Those are really main ones you see. And again, you might have more than I wrote here, but these are some of the general ones that you normally see. So now we're going to use this in our next part of the lesson. And this is writing algebraic expressions. So I have here another table, oh boy, and we have the word phrase and the algebraic expression. All right, so on most of these we have to write them as an algebraic expression. However, there is one where we actually have to write it as a word phrase. So we're going to start here at the top. 7 more than y. Now what I like to do first is find that key word. Find those words that tell me if I'm adding, subtracting, multiplying, or dividing. And this more than here helps me figure it out. More than. More than means to add. If you look back at our list, I think I had more than under that addition sign. So we have 7 more than or plus a number y. Well, you can write it in this order. 7 plus, well, that number, again, they tell us the number is y. So you'd write 7 plus y. Or, because it's addition, you could actually switch it and write y plus 7. When you're adding, it doesn't matter the order. All right, and there we go. Then we have this one, the second one here, 12 less than the number d. And again, we're looking for those key words, and if you underline them, if you want to do this at the same time as I am, you should find less than. Again, look back at your list. Less than means to subtract. Now, when you're subtracting, you have to be careful, because some people will just want to write 12 minus d. But that is not right, because we have 12 less than the number d. So you're basically taking d and subtracting 12 from it, because it's 12 less than that. Those are not the same things. So when you subtract and divide, actually, you need to be careful to write it in the right order. Adding or timesing doesn't really matter. All right, then we have the third one, 3 times f. Again, that times tells me what operation, and that means to multiply. So I could write 3 and then that times sign f. Or, as I said, you don't even need that times sign in there. You could just write 3F. Means the same thing. All right, then we have this fourth one where we're working backwards. And what's fun about these is usually how you say them, that's how you can write them. If I take a look, I have A, so I could write the number A, or just A. And then, well, we had two ways we could say divided by, or how to divide. And usually we write A divided by 4. That would work. Now, you do want to be careful when you use the word quotient, because you don't want to say A quotient by 4. That doesn't make sense. If you're going to use the word quotient, you actually say the quotient of A and 4, or between A and 4, and so on. All right, so just be careful how you say them sometimes. And then finally, we have this one. And this one's a little trickier because there's a few things in here. 4 times the quantity 5 plus C. Now, if you take a look, we actually have two keywords that we've talked about. We have the word times, and we have the word plus. Now, with these ones, what's going to help us here is the quantity. The quantity usually means when you put it together. All right, now when we're talking about the quantity 5 plus C, when you're talking about something like that, that means those go together. So really, the quantity means 5 plus C in parentheses. And then we have 4 times that. So I could write 4 times the quantity, 5 plus C, or just 4 times 5 plus C. Again, both of those are right. All right, and again, the main idea here is an algebraic expression is just an efficient way or an easy way to express a mathematical detail or an expression. All right, next page. Oh, there's a matching piece, matching the expression to the phrase. Let's see, why don't we go ahead and do this? Again, we can do them together. 7 minus the number C. Well, I see that keyword of minus, so I know I'm going to subtract. And ooh, this is an interesting one because there's really 2 with C and 7. Now, again, read it carefully. 7 minus the number C. All right, on this one, they're taking away that C. So really, yes, 7 does come first on that one. All right, go ahead and finish the rest of them, and then when you're done, why don't you check them to see with what I had. Go ahead and pause now. All right, welcome back, and I hope you finished this, matching activity. We're just going to continue through. The number D increased by 12. Well, that would be D plus 12. A number Z times 6. And again, you probably might be looking for Z times 6, but that's not quite here. Instead, they have it written as 6 times Z or 6Z. Same idea. Then the number C minus 7. Well, you're taking away 7. That goes down there. The difference between P and 4 is right there. And the product of U times 1. Now, anything times 1 is just the other number. So they could have written this as 1 times U or 1U. But it's really not necessary because U means the same thing as 1 times U. All right. Now, we have a word problem, and we're going to talk about ALCO. And we need to write an algebraic expression for this word problem. Pens at ALCO cost 29 cents each. Write an algebraic expression for the cost of pens P. So if we just basically list the information we have, or even underline it, we know, well, ALCO has pens, and they cost 29 cents each. For every pen, you're going to pay 29 cents. All right? But, again, we don't know how many pens you bought. You could have just bought 1. You could do 29 cents times 1. Oh, that's 29 cents. You could have bought 2 and have 58 cents. And so on. And that could continue. It could go all the way up to 100. Maybe someone needed pens and bought 100 of them. Who knows? So we get to that point where we have P. And again, we don't know how many they bought, but we know they're 29 cents each. So if you follow the same idea, well, we were multiplying. So you get Well, 29 cents times P, or if you wanted to write it as a decimal, 0.29 times P. All right, either one of those would work. You could have that first one, you could have the second one, either one. But again, we had to tell the cost for pens. So that's what we'd write. All right, and then we have this one. Emily has twice as many sports cards as Jose. Then she buys four more for $2 each. Use the variable x to write an expression for the total number of sports cards Emily has. So this one, they actually lead us through it. Number one, what does x stand for in this problem? Well, if you go back to the bold, use a variable x to write an expression for the total number of sports cards. So in this one, it should lead to sports cards. X is going to tell us how many sports cards she has. Now, number two, what operation would you use to represent the phrase twice as many sports cards? Now, twice as many. So, you have double. Twice means to double. All right? You can't do x plus x here. Twice is another way of saying 2 times what we had before. So 2 times x. And then use the variable x to write an expression for the total number of sports cards. So, Emily has twice as many, and I know you can't read down there, so we're just going to basically write the answer here. Basically, write how many sports cards she has. Well, we know she has twice as many as Jose, so 2 times x, she has twice as many sports cards, 2x, and then she buys 4 more. Well, she added 4 more to her collection. If she added 4 more, we're going to do plus, well, those 4 extra. That would be our expression, 2x plus 4. And that's the end of your first lesson. I hope you enjoyed it, and I hope you are ready for class tomorrow. See you then. Bye-bye.